Alright, so in this video we will talk about how to turn alkenes into alcohols. So the first method, which was described in a previous video, was using acid-catalyzed hydration, and that was simply treating an alkene with some kind of acid. It could be hydronium, HCl, or even H2SO4 in water, and that would yield a alcohol. Now, the alcohol that would yield is the alcohol group would be attached to the most substituted carbon, and this is due to Markovnikov's rule. So I'll just write it short for Mark. And in this reaction, because there's a carbocation intermediate that's formed, we also get rearrangement that can occur. For example, if we had some kind of a compound like this, and we treat that with H2SO4 over water, we would get this compound. As you can see, because there's a Markovnikov arrangement, normally it would attach here, but because rearrangement can happen, there's a methoxide shift from there to here, and the alcohol is attached here instead with this methyl group here now. The second method we will talk about is oxymercuration, demercuration. So oxymerc, demerc for short. And it's almost the exact same as acid-catalyzed hydration, except we use mercury acetate complex, H2SO4 or H2O, and we also reduce it later with sodium borohydride. And our product that we get is this. Now in this reaction, it's also Markovnikov, so the alcohol is going to attach at the most substituted, but there's no rearrangement. Rearrangement. This is due because the intermediate, when the alkene attacks this compound, is not strong enough to shift. If you guys would like to see a mechanism, leave it in the comment and you'll know why in the mechanism. So a final way to do it would turn an alkene into alcohol is through hydroboration. In this one, the alcohol is treated with a buran tetrahydrofuran complex, so BH3 THF, and then it is treated with peroxide and a base, O2 and OH minus. Now the products of this is also an alcohol, but the alcohol is attached to the least substituted carbon, and so this is anti-markovnikov. Anti-mark. There's also no rearrangement. This is due to the mechanism as well, and if you guys would like to see that, once again, leave in the comment. Also in this one, there's a syn attachment with the alcohol and the hydrogen here. So if we had a cyclic alkene, like that, and we treat it with BH3 THF over H2O2 and OH minus, the hydrogen and the alcohol that attach would be syn, so they would both be pointing up or both be pointing down. Once again, this is due to the mechanism, so yeah. One thing to keep in mind is if you guys have a branched hydrocarbon and you want to attach it at the most substituted part, the alcohol, you would probably want to use oxymerc demerc for a chance of some crazy rearrangement due to carbocation. Other than that, no rearrangement, then you would use acid-catalyzed hydration. If you want to attach it at the least substituted side, use hydroboration. All right.